Welcome back to the series where I am building a self-tracking app in Svelte 5. This week we're going to start with the actual code of the application. Now that we have some basic Figma mockups of how we want the design to look, we're also going to start designing the code and planning how we want the code to be connected. And at the base of the app, we're going to have Svelte 5. And this is going to be vanilla Svelte, since we have no interest in making a backend in SvelteKit. So we only need the front-end framework of vanilla Svelte. For styling, I'm going to use my beloved Tailwind CSS to rapidly compose the styles from utility classes, rather than creating cumbersome dedicated CSS classes that we just have to figure out the names for. We're going to use the built-in Tailwind CSS classes. And this app will also be local first, like I mentioned in the first video. So we're going to need a storage solution that works locally in the browser as well. I have previously played around a bit with projects like SQLite in WebAssembly and even PGLite, which is a really cool project that is embedding a PostgreSQL database right in the browser. But sadly, I don't feel like they are quite mature enough. And it still seems that IndexedDB is the fastest in most cases and definitely the easiest to set up. And keeping it in IndexedDB will also make it really easy to store the usual JavaScript primitives like objects or arrays or even binary data. So it seems like the best choice right now. But later down the line, we might see how these other libraries have progressed and maybe they have become more viable then. For IndexedDB, I'm going to use the awesome Dex.js library, which is practically a wrapper around IndexedDB that makes it much easier to work with. The vanilla IndexedDB API is a bit rough around the edges. But if you want to learn more about this Dex.js library, I recommend you checking out the video that I made on storing things in IndexedDB. So now we have the storage solution, we have the styling, we have our beloved Svelte, but how are we going to represent the different routes in our application? Since we're not using something like SvelteKit, we're not going to have a built-in router. And this is still a single page application. So I'm going to use a hash-based router, which will determine the route from the hash in the search bar. So we will stay on the same route, but having a different hash will simply render a different component in the front end. A neat library for this has previously been Svelte SPA router. I'm not really sure how well this works with Svelte 5 now, so we're going to have to take a look at that in the future when we are going to set up a routing. But let's start by just creating a new Svelte project. So now we have a project with Svelte, Vite, Tailwind CSS and Dex.js set up. It's time to start designing the code, thinking a bit about what entities I want to have in the program, what kind of functionality, a bit how I want to connect these different aspects. So drawing up some diagrams and see where that gets us. All right, so now I have set up the most fundamental components of the app, the core entities, so to speak. We have these trackables, forms, and journal entries. So trackables are really the base entities for something that you can track in the system. It might be something like steps or resting heart rate or food or whatever you can think of. And then there are forms, and these are where the user actually types in their data. So if they type in that they are feeling anxious, or they're typing in that they took X amount of steps and things like that. So you're also going to have to specify what kind of type that you want to have for this form question. I have thought of some that I had in the previous system. You have text and numbers and dates and even things like rich text. And yeah, all of this really corresponds to that design that I made in Figma. We had things like inputs and selects, and then we also have settings for these specific data types and display types. So we might say that this text should have a minimum length of a specific amount of letters. And we also have the display settings, which are more important for things like selects, where you actually define the options for this select. So if you want to have 1, 2, 3, 4, 5 as select options, then you're going to have that represented as an object. So this journal entry is a specific entry that the user has logged. Let's say they logged a mood of 7 at 12:31 on a Tuesday. Well, then we have a journal entry with that specific Unix timestamp and the specific answers that they inputted and the form ID that corresponds to. And yeah, this is pretty much the history of the whole application. If you were to ask for what I'm gonna store the most, or what I'm gonna spend the most storage size on, well, it's going to be the journal entries most likely, because that's where we're gonna have the actual data, the whole history of everything that the user has ever inputted. So I want a pretty dynamic system where the user can log entries, but also update them if they are perhaps unhappy. So let's say they update an entry, then that should also be reflected in any charts that we have in the system or any tables. So another problem that we need to handle is if the user tries to make any sudden changes to a form. Let's say they add a new field, how happy did you feel while waking up? Or maybe they even deleted a field. Well, then that won't really exist to be shown or displayed in the journal entry anymore. So we're going to have to need a way to historically keep track of all the forms in the system. So that's why I have a form snapshot as well. So whenever the user makes a change to a form, we will be creating a new corresponding form snapshot. We're also going to be updating this snapshot ID. So I notice now that, of course, this should also be included in the journal entry. That's the whole point, is that we should have the snapshot saved in journal entry so that the system knows how the form looked at that point in time. Now, how are we going to achieve this reactivity that I was talking about? Well, in the previous version of this app, I had a concept of a variable. So much like the variable in your favorite programming language, we have some sort of dynamic value that will be updated and evaluated from data in the system. So we might have something like a hydration list that will return a list of all the journal entries with a specific question attached to it and things like that. So that's something I'm going to try to model now to my best ability and see if we can come up with some form of solution that will help us achieve this reactivity. So now I have done some planning for this variable system that I was talking about as well. And how do I want this to work? Well, so this aggregate variable will fetch this list variable and then do some sort of calculation based on that. So this aggregate, for example, might sum up all of these values. You might have a list of hydration. You might have measured how much you drank during the day. Maybe you drank 250 milliliters, then 500 milliliters, and then 1,000 milliliters. You felt super thirsty. Then you have a total hydration variable that will be dependent on that, and then calculate and sum up all of these individual values into one value that this aggregate variable returns. And this should also be reactive. So whenever I change a journal entry that is matched within this list variable, then we want this one to reevaluate again because it has a new value. So the way I thought about modeling this is with the help of a graph. You know, these cool spider web thingies where things are connected to each other. It's going to be a directed acyclic graph, a pretty fancy term, but it simply means that we're going to have directions because variable A depends on variable B and not the other way around. We have an actual direction of the arrows that we are connecting. And acyclic simply because we're not going to have any cycles. We shouldn't have variables that reference themselves because that would lead to infinite recursion. So we're going to have a graph where we connect these variables. If I have, let's say, an aggregate variable, then that aggregate variable will depend on another list variable. So you might form these sorts of spider webs with dependencies. And I did some rough sketch of this, but then we also have the dependence. So this is where the edges will be stored. So we're going to store a mapping of the variable ID to a list of all the variable IDs that depends on it. So if we have this list variable, then this list variable will have an entry here, and this array here will contain this aggregate. So we can check then whenever this value has updated, whenever this list variable has updated, we can get all the dependents for that variable, and then we can reevaluate them. So I did something like reevaluate dependent variables and things like that. All this is surrounding a time context. You want to get this list for a specific day, or maybe you want to get it for a specific week, or you want to get a custom time range. So we have some different time range types, such as a simple time range, which might just be daily, weekly, or monthly. We can also have a range. We can also get forever, so we get all the entries that ever existed. And then the basic idea is that whenever we have calculated a variable, we're going to store that in a variable index. So we're going to store this specific variable ID had this specific value for this specific time scope and timestamp. So this will simply be an index so that we don't have to recalculate it every time. So this is the basic idea that I had for this system. But of course it's not set in stone by any means, but I feel done with this for now, so I will see you another day. Alright, welcome back to another day, and today we're going to continue the design for a little while. We're going to set up how we want to communicate with Svelte. Things like stores, and maybe even bringing in some components just to see how we're going to connect the view to some of the more back-end kind of details. So let's get going. Alright, so now we have some of the stores set up and also some of the other key aspects of the system. So I thought of having these sort of stores for just the entities themselves. We're going to have lists of trackables, and that will be a promise of trackables. This will be a store that returns a promise, simply because this has to be fetched from a database. We need to fetch this from the trackable service, which in turn we're going to have a trackable collection. I thought of making this an interface so that we could perhaps have other storage solutions in the future as well. So this variable and variable range store will be fetching values from our variable graph. And in turn, we are going to have a trackable value. So this will be either a variable ranged or a variable, depending on if this is a chart. So if this trackable wants to render a chart, we will need to have some more history. We want to show perhaps the last 7 days of steps. Then we need to have a variable ranged because we're going to have this variable, then we're going to have a starting date and also a time scope. So maybe daily then, and then you want to count back 7 entries, 7 variable values, because we need to calculate a specific variable value for this date. And then we're also going to have these Svelte components down here. We're going to have a trackable list component. It will have multiple of trackable cards, and the trackable cards themselves will be responsible for fetching the value from the trackable value store. So we don't need to have that inside of the trackable list, because then we would have to re-render the whole trackable list even if only one trackable value changed. So now I think it's time to actually start writing some code and seeing how we can implement this within TypeScript and Svelte in our project. All right, so now we've got some of the basic project structure up and going. We have some form of directory structure here with components, we have DB, some model, services, stores, views. And this is of course not set in stone. We'll probably change it a lot, but this is my basic idea. I also started implementing these primitive values that I had in my design. And these are simply kind of wrapping around some of the JavaScript primitives like strings and numbers and booleans. So it's really nice with these union types in TypeScript. We can say that this primitive value might be any of these. It might be a string, but if it is the string, then it must have a string value, or we can infer that this will have a string value. So if I check in my code, does this type equal primitive value type dot string, then we can with reasonable guarantee assume that we will have a string in the value prop. Alright, so now we have a very basic app setup where we can create new trackables. So we can create a new trackable, and I also start saving this into index.db. So if we go into the purpose DB, you can see that has shown up there. So that seems to work pretty nicely. Good morning, sunshine, and welcome back to another day. So now I've actually implemented a variable system for my trackables. I actually implemented that variable graph that I was talking about, and also some of these variables stores that will give us this reactivity that we want in the application. So now we can create new trackables. We can create a new trackable and it will show up reactively in this list, and we will also have a variable associated with it. We'll actually have two variables associated with it. So we'll have one list variable which will return journal entries, and also an aggregate variable that will sum up these values. So if I were to log something here, let's say I logged a 20, boom, we can see that reactivity update. But we can also log another value. If we log 50, boom, we get 70. So the math seems to work out right. And we can see that this is working against these journal entries. So if we take a look inside of this, we can see that it stores these numbers in the entries, and then we can dynamically calculate that in the variables themselves. So you can see that this is a sum aggregate. It sums over this list variable, so it's depending on that one. And this one wants to fetch the test field from a journal entry. So we have some of that reactivity working. And of course, this also works if we have multiple trackables. If I log this independently of the other one, we will see that it has a different value. So now we have this variable graph where we can now add variables that we will reactively update and have dependencies between them. So yeah, I implemented this directed acyclic graph kind of system. So whenever something updates, like here, we check all of the dependents, and then we also make sure to reevaluate those dependent variables. So then depending on the type of the variable, we will get a different value. So if we have a list variable, then what does this actually do? Well, it will get all the entries in the time range, and then it will extract these questions that we asked it to extract. And we also have some listeners. So when a new journal entry is created, we make sure to update the existing variable index, so that will be updated. And then I also made this reactive then with a Svelte store. Well, first and foremost, we have this variable service that will let us add a live query, so to speak. We query a variable and then we have a callback. So whenever this variable value updates, we'll get a call to the function that we passed in here. So we have an update listener, and we just call that whenever the index has updated. So we also model this with a store in Svelte. If we take a look inside of our trackable card, we can see that we have this variable store. It uses the trackable ID, and we set this time scope of a daily. We want a daily value. If we wanted a weekly value, we could have the total hydration for a whole week, but we just want a daily value. And then we have this this is also async, so we are using this really nice feature of Svelte where you can have a async rendering. So whenever this is loading, we are awaiting it, and then when the value has come in, we actually start rendering it. So we just render the value. So how does this store work? Well, we have a new variable store. And this is quite complex. It looks a bit nasty, but it's pretty nice. We have just normal Svelte store with a writable, but we also have a variable context. So we need to make sure that when this variable store is destroyed, perhaps when we unmount a component, we actually unregister these listeners. Otherwise, we're going to have a bunch of listeners being called for components that are no longer being rendered. So we just unregister that here. But then we have a new promise. So this is a store. It's an actual readable or writable that returns a promise. So it returns this promise, and in this promise, we then evaluate this variable. And when the variable has updated, we send in this callback. So whenever that has updated, we also update the Svelte store. So now it's really nice because I can just set up this Svelte store and I specify a name of a variable, and then all of a sudden, boom, this is reactive in Svelte. So whenever this variable changes its value, we will get that updated in the browser as well. So I'm really happy about that. I also created some testing for this, so to make sure that this graph is working, we have some different test cases. New entry has come in. Well, then we want to update this average that we previously calculated. So this seems to work. If I run this test, we can see that, yeah, in fact, it returns the correct value, which should be 31. So I'm really happy about the progress this week. We are really coming a long way already, and it's really much more productive working with just web technologies, not having to write the same code twice. So I hope you guys follow along for next week as well, where we continue with this system. Perhaps start adding a bit more content to the page, more components in Svelte, and connecting all of it together. But if you enjoyed this video, feel free to give it a like, and also feel free to join my Discord channel if you want to be part of the community. But other than that, I'll see you guys next week. Peace out.